I need to tell you about something that just happened with 3i Atlas, and honestly, it's got me sitting here at my desk just staring at these new images NASA dropped today. This comet, this interstellar visitor that came from somewhere beyond our solar system, looks completely different than it did just a few days ago. And I don't mean different in some subtle technical way that only scientists with fancy equipment would notice. I mean different in a way that makes you do a double take when you see the images side by side. Let me back up for a second, because I want to make sure we're all on the same page here. Before we continue, if this has your attention, you can subscribe, turn on notifications, and hit like anytime. And for the best viewing, switch to full screen and enjoy what's coming next. So, 3 Atlas is an interstellar comet. That means it didn't form here. It formed around some other star in some other solar system, and it's been traveling through the void of space for who knows how long before it happened to pass through our neighborhood. We've only ever confirmed a handful of these interstellar objects, and every single one of them has taught us something completely unexpected about what's out there beyond our little corner of the galaxy. This one showed up, and like any good comet, it started putting on a show as it got closer to the sun. The heat made it active. Gas started streaming off. Dust got kicked up. It developed that classic comet look, with the glowing head and the tail streaming behind it. We've been watching it, studying it, taking measurements, and trying to understand what makes an interstellar comet tick. But here's the thing. Over the past few weeks, 3i Atlas has been changing. Not just getting brighter or dimmer, as it moves closer to, or farther from, the sun, actually changing the shape of its glow, the pattern of its jets, the way it spins, even the material it's throwing off into space. It's been transforming right in front of our eyes. And today, NASA released a new set of images that show just how dramatic that transformation has become. So, let me walk you through what we're seeing, because this is genuinely wild. NASA put together a side-by-side comparison using images from last week and images from today's same telescope. Same filters, same exposure times. They wanted to make sure they were comparing apples to apples, that any differences we're seeing are real and not just artifacts of how the images were taken. In the older image from last week, 3 Atlas looked like what you'd expect a comet to look like. You had this bright, slightly stretched inner region called the coma, which is basically the cloud of gas and dust surrounding the actual solid nucleus of the comet. And then you had this tail, this long streamer of material being pushed away from the sun by solar radiation and the solar wind. Maybe a few faint jets here and there, some subtle structure, but overall, it had that classic comet appearance. Now look at today's image. The shape is completely different. That inner coma, that glowing cloud around the nucleus, it's not round anymore. It's not even slightly stretched, it's flattened. It looks almost disc-like, like someone took the comet and squashed it from top to bottom, and right across the middle of this flattened disc. There's this sharp, bright ridge, this intense line of light cutting horizontally through the center. Above and below that ridge, the glow is softer, more diffuse, like a halo. And the tailo, man, the tail. Last week, it was one main stream, one clear direction, where material was flowing away from the comet. In today's image, that single tail has split into two distinct branches. It's forked. It makes this wide V-shape spreading out behind the comet. And that structure just wasn't there before. It's like the comet went from looking like a regular street lamp to looking like a glowing boomerang in the span of a few days. That visual change alone would be interesting, but it gets deeper than that. They also analyzed the color of the light coming from different parts of the comet, and that's changed too. In the earlier images, 3 Atlas had this fairly uniform greenish-white color throughout most of the coma. That color came from a combination of gas emissions and sunlight reflecting off dust particles. It's what you'd expect from a comet doing normal comet things. In the new images, the inner region, that bright disk with the ridge across it, is noticeably wider. The light is harsher, more intense, but when you look at the outer parts of the coma, and especially those forked tails, the color shifts. It gets slightly redder. Now, you might be thinking, okay, so what? It changed color a little bit, but to the scientists who study comets, this color change is a huge deal. It's telling us something fundamental about what's happening inside this object. When you see whiter, bluer light from the inner regions, that usually means you're getting more scattering from very fine dust particles, or you're seeing strong emission from excited gas molecules. When you see redder light in the outer regions, that typically means you have larger, darker dust grains dominating that area. What this tells us is that 3 Atlas isn't just throwing out the same material in a different pattern. The actual composition of what's being ejected has changed. We're seeing different stuff coming out now, compared to what was coming out before. The comet is literally exposing and ejecting different layers of itself, and the polarization data backs this up in a really interesting way. Part of today's data release included polarization maps. Without getting too technical, polarization measurements tell you about how light scatters off particles. And from that, you can learn about the size and texture of the dust particles doing the scattering. In the older polarization maps from earlier observations, the pattern was pretty symmetric. You had the strongest polarization around the edges of the coma and weaker polarization near the center. That's standard behavior for a comet. Nothing surprising there. In the new polarization maps, that symmetry is gone. There's this band of high polarization that lines up perfectly with that bright, flattened ridge we're seeing in the regular images. And then, above and below that ridge, in those softer halo regions, the polarization is much lower. What this means in practical terms is that the dust filling that disc-shaped region is physically different from the dust in the surrounding halo. It's probably more compact, more uniform in size, different material with different properties. So, when you put it all together visually, physically, and structurally, 3 Atlas looks different now, because it genuinely is different. This isn't an illusion or a trick of the light. The comet has actually changed. But the story doesn't stop with images and color and polarization. There's more. The light curve changed too. A light curve is a graph showing how bright an object gets over time. For a comet that's spinning, you typically see the brightness go up and down in a repeating pattern as different parts of the surface rotate in and out of view. Some parts might be more active and throw off more dust, so they look brighter. Other parts might be quieter, so they look dimmer. As the comet spins, you see this regular variation. A few days ago, when scientists looked at the light curve for 3E Atlas, they saw this messy double-peaked pattern. There was one strong maximum one point in the rotation where it got really bright, and then a second maximum that was a bit weaker. As it continued spinning, the brightness would drop, then rise to the strong peak, drop again, rise to the weaker peak, and so on. In today's data, that pattern has changed. Those two peaks have almost merged together into this broad, flat plateau. Instead of the comet flickering between bright and dim as it rotates, it's now staying at high brightness for a much larger fraction of each rotation cycle. This tells us that more of the surface is active now. More areas are throwing off gas and dust simultaneously, instead of just a few isolated spots lighting up as they rotate into sunlight. And this ties directly into that new flattened disk shape we're seeing. Think about it this way. If the nucleus, the solid core of the comet, has developed a continuous belt of vents around one latitude, like a ring of activity circling the comet, then, as it spins, that entire belt keeps feeding dust and gas into space. Instead of narrow jets shooting out from a few specific spots, you get this broad, continuous flow, creating a flattened disk of material, which is exactly what the images show. This also means that the total amount of surface area that's actively shedding material has increased, and more terrain is involved in the outgassing process. Now, this is where things get really interesting from a dynamics perspective. When NASA's orbital mechanics teams input today's position data for 3I Atlas into their models, they weren't just checking where the comet is in space. They were checking how the outgassing is affecting its trajectory. When a comet throws off gas and dust, it's not just creating a pretty display. That material carries momentum. As the gas jets away from the surface, it pushes back on the comet itself, like a tiny rocket engine. We call this effect non-gravitational acceleration, because it's a force acting on the comet that has nothing to do with gravity. The non-gravitational term for 3 Atlas hasn't gone away. It's still there. But with this new belt-like activity pattern, the character of that acceleration has changed. It's become less spiky and more continuous. Instead of occasional outbursts, giving the comet random short kicks in different directions, the comet is now experiencing a steadier, more evenly distributed push. Now, that might sound calmer, more stable, less dramatic. But here's the thing. A steady wide belt of vents doesn't just push the comet in a straight line. It can also produce a consistent torque on the nucleus. Instead of occasional jolts that spin it up in spurts, you get a long, sustained twisting force acting on it. So, let me just summarize where we are, because there's a lot of pieces to this puzzle. We have a new disc-like inner coma with a sharp, bright ridge. We have a forktail structure that wasn't there before. We have a color shift, with whiter light in the center and redder light in the outer regions and tails. We have a broader, flatter light curve showing more sustained brightness. And we have a smoother but still significant non-gravitational acceleration affecting its orbit. Every single diagnostic we have, every measurement we can make, is telling us the same thing. 3E Atlas looks different now, not just cosmetically, but fundamentally. So what caused this transformation? The most likely explanation is that the heat from the comet's close approach to the Sun has finally reorganized the outer layers of the nucleus. Earlier in this encounter, when the comet first started getting active, the outgassing was dominated by a few strong fractures and jets. These were weak points in the surface where gas could escape, and they created those narrow, focused streams of material we saw in the early images. But as those regions kept eroding, as more and more material got stripped away, the stress on the surface got redistributed. Cracks that were separate might have linked up, new fractures might have opened. Eventually, instead of a few isolated vents, you end up with a larger, connected band of active terrain running around the comet. When that band opened up enough for gas and dust to flow more evenly across a wider area, The comet snapped into this new mode we're seeing now, less dominated by individual jets shooting out from specific spots, more driven by this continuous strip of active surface. And that would explain everything we're observing. That explains why more of the rotation is bright, because there's more active surface visible at any given time. It explains why the inner coma looks flattened, because material is being fed into it from all around this equatorial belt. It explains why the tails fork, because dust is being pushed out in slightly different directions depending on where along that belt it's being released. And it explains why the dust properties have shifted, because now we're not just seeing material from a few surface fractures. We're tapping into deeper layers across a much wider zone of the nucleus. Here's what makes this particularly unsettling. Though this is not a cooling down signal, this isn't the comet running out of steam and going quiet. This is an adaptation. 3E Atlas didn't just calm down and fade away. It reconfigured itself and kept going strong. If this new configuration is stable, if tomorrow's images, the next day's images, and next week's images all show the same disk, the same forked tail, the same broad light curve, then what we might be witnessing is the comet settling into what you could call its final form for this pass through the inner solar system. This could be the configuration it maintains as it heads back out into the darkness of interstellar space. But, if it's not stable, if the disk warps and changes again, if one fork of the tail gets brighter while the other fades, if the rotation period keeps shifting, then today's snapshot is just another frame in a longer sequence of transformations. Today's version of 3E Atlas might not be the final version at all. It might just be the latest version. And here's what really gets me about all of this. This is not some old, familiar comet that we've watched make trip after trip around the sun. This isn't Halley's Comet coming back for its 30th visit, or some periodic comet we've studied for decades and think we understand. This is an interstellar object that it formed around a different star. It grew from a different protoplanetary disk. The materials that make it up, the ices, rocks, and organic compounds frozen inside it, they all came from somewhere else. A different stellar environment, with different chemistry, different temperatures, different radiation conditions. The internal structure of this thing, the layers it has, the way it's put together, we've literally never seen anything like it before, because everything else we've ever studied came from our own solar system. We're not just tracking where it goes, we're watching what it becomes. We're watching an alien object transform under conditions it might never have experienced before in its entire existence. For all we know, this could be the first time this comet has ever gotten this close to any star. This could be its first and only passage through an inner solar system anywhere in the galaxy, and we just happen to be here, with our telescopes pointed at it, watching it unfold in real time. The images NASA released today might be the clearest look yet at this transformation process. They might represent the moment when 3E Atlas finished its reshaping and settled into a stable mode. Or they might just be a particularly dramatic frame in a longer movie that's still playing out. We won't know which it is until we see what comes next. While tomorrow's images show the same disk, the same forked tail, will the light curve stay flat and broad? Will this be the version of 3E Atlas that we remember as it heads back out into interstellar space? Or will it change again? Will we log in tomorrow or next week and see something completely different yet again? Another transformation, another adaptation. That's what makes this so compelling. We're not watching a static object. We're watching something dynamic, something that's actively responding to its environment, something that's revealing new layers of itself as it gets heated, stressed, and pushed to its limits. And every new image, every new dataset, every new measurement could be the one that shows us something we've never seen before. That's why I can't stop staring at these new images. That's why I'm sitting here trying to convey to you just how significant this is. We are witnessing something genuinely unprecedented, an interstellar visitor transforming before our eyes. And we have no idea if what we're seeing today is the end of the story or just another chapter. The only thing we know for certain is that 3 Atlas looks different, now measurably, undeniably different, in whatever comes next. Whatever this comet decides to show us in the coming days and weeks, I can promise you it's going to be worth paying attention to, because we may never get another chance like this. We may never see another interstellar comet put on a show like this in our lifetimes, so that's where we are. That's what NASA dropped on us today. A comet that doesn't look like it did last week. A comet that's changing faster than we expected. A comet that keeps surprising us. And I, for one, cannot wait to see what it does.